Users couldn't run queries, dashboards errored, and the Snowflake web UI was gone. The account was single region with no replication, one outage, total blackout. Let's explore. You'll learn how to set up database replication, perform failover and failback, and implement a comprehensive disaster recovery strategy. By the end, you'll be able to configure Snowflake for high availability and confidently handle outages. Snowflake Disaster Recovery uses replication and failover to maintain data availability. Replication is asynchronous, copying data from primary to secondary accounts. Its lag determines your RPO. Failover switches to the secondary when the primary fails. Failback reverses the process after recovery, enabling business continuity. Snowflake's primary account separates storage and compute, enabling unique Doctor capabilities. Replication is asynchronous per database. Lag determines RPO. Data replicates to a secondary account. Business Critical Edition adds enhanced replication, failover, and failback. First, confirm replication is set up from your primary account using show replication databases to check status. Then monitor lag in replication usage history to ensure your RPO is met, catch issues early, and plan for acceptable lag. Run these queries to see which databases are replicating and how much lag exists. The lag is in seconds. To set up replication, you need at least 2 Snowflake accounts on Business Critical Edition. Enable replication on the primary, create a link, enable replication for each database, and create the replica on the secondary. Run these commands on the primary and secondary accounts. Note, initial replication for large databases can take hours, so plan accordingly. First, verify the secondary is healthy. Then, during a disaster, you manually promote it to primary. After promotion, update the connection strings to point to the new primary. Finally, when the original primary is restored, you reverse replication and fail back. First, promote the secondary and verify with system $global account current region. After the original primary is restored, enable replication back, promote it again, and verify. Update connection strings at each step. Automatic failover uses client redirect. After the secondary accepts failover, you can optionally create a failover group. When the primary fails, Snowflake redirects new connections to the secondary. Existing connections may drop. Configure failover object on the primary and accept on the secondary. Optionally group databases. Always test in non-production first. Continuous monitoring is essential. On the primary account, start with show replication databases to see your replication setup, then query replication usage history for detailed lag metrics. Also check failover events. Set up alerts to notify you when lag exceeds your RPO. These queries use current timestamp and DATADD to check lag over the past hour, system $last replication timestamp for the last replication point, and failover event logs. Use them to build dashboards. With Business Critical Edition, you start with a primary in Amazon Web Services, then replicate to a secondary in Azure or GCP. This enables failover for ultimate resilience and avoids vendor lock-in, though it adds complexity and cost. Ensure data sovereignty compliance. The sequel is similar to cross-region replication. Just use the secondary account locator for the target cloud. Regular testing is critical. Start with a test plan, automate failover drills using Snowflake's SQL API or Terraform. Verify data consistency after failover. Then failback. Document the exact commands and contacts and review the entire drill to close the loop. Run these commands in a non-production environment to simulate failover and failback. Verify data and lag at each step. This is the chain reaction that unfolded. The account was single region with no replication enabled. When the region went down, there was no secondary to failover to. The developer assumed built-in redundancy, but Snowflake requires explicit configuration. The fix ensures that when a user query hits the primary account, we have database replication to a secondary region and automatic failover configured using alter account set failover object. So if the primary goes down, Snowflake automatically redirects connections to the secondary and service is restored. The most common mistake isn't enabling replication at all. Without a secondary, you can't failover. After you enable replication, like this alter database command, the target account becomes a failover secondary, protecting against data loss. The mistake here is leaving out the explicit failover configuration. Without alter account set failover object, Snowflake won't redirect connections during an outage. The fix adds that command, targeting myorg, my account, which explicitly sets the failover object and enables automatic connection redirection. After failover, a hard-coded primary URL like JDBC, Snowflake //primary account, Snowflake computing, com breaks. Instead, use a DNS-CNAME such as JDBC, Snowflake //Snowflake, my company, com to automatically redirect to the new primary, no code changes needed. Use these commands to diagnose Doctor issues. Check failover mode, verify secondary account status, monitor replication lag, and query the last timestamp using system $last replication timestamp to ensure your Doctor plan is working. Interview prep time, interview questions. Understand replication mechanics, failover steps, and cross-cloud considerations. Time for frequently asked questions about Snowflake Disaster Recovery. To summarize, replication is asynchronous, so monitor lag. Automatic failover must be configured. Cross-cloud replication provides ultimate resilience, and always test your failover procedures. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.